All right, here's another example of some verifying trig identities. Notice that this problem has two sides of the equation. Remember, we cannot work across the two sides. We are showing that these two things are equal, so we cannot assume. If we go back to our list of strategies, we see start with the most complicated side. We've just talked about that. We can't really combine fractions with common denominators. Everything's already in terms of sine and cosine. We might need to remember our algebra skills, but we really can't factor. So we're going to go back up to this one. This can I make a trig identity? Well, if we look at this, let's remember what our trig identities are. One of the trig identities is sine squared of theta plus cosine squared of theta equals 1. If I solve this for, let's say, cosine squared of theta, I would subtract sine squared of theta from both sides. And I would have that cosine squared of theta equals 1 minus sine squared of theta. Well, let's think back to algebra 2. If I had 1 minus y squared of theta, what is that? Right, that's the difference of two squares. And so that would factor into 1 minus y, 1 plus y. Or, in this case, 1 minus sine of theta times 1 plus the sine of theta. Well, I have 1 plus the sine of theta right here. If I multiply the bottom of it by 1 minus the sine of theta, I'm going to end up with this trig identity. But whatever I do to the bottom, I have to do the top. Although instead of theta here, we should be using x because that's... So let's change that to an x. All right. 1 minus sine of x times the cosine of x all over 1 plus the sine of x times 1 minus the sine of x. If I FOIL those two things together, though, and I can go ahead and distribute this, but so we get cosine of x minus cosine of x times the sine of x. And on the bottom, we get 1 minus, 1 times 1 is 1. We get a plus sine x and a minus sine x. Those are going to cancel out. And then minus sine squared of x. But if we look over here, 1 minus sine squared of x is cosine squared of x. So our denominator is cosine squared of x. Our numerator is cosine of x minus cosine of x times the sine of x. Now maybe what I wanted to do is instead of, if I had left this unmultiplied out, if I had left it factored, I might see something I can do. So I'm going to factor that cosine of x back out. Now, if I have a cosine of x and a cosine squared x, and I'm multiplying, what can I do? Right, that can end up being canceled. So I end up with 1 minus the sine of x over the cosine of x. But I believe if we look back, that's exactly what we had. And so we have now verified that trig identity. It's really important that you know these trig identities and that you realize what the manipulations of them can look like, and especially that you remember your algebra skills and that you remember how to factor in order to verify them. That's a really great skill to be able to have.